Happy May 20th, everyone. My name is John. I'm a senior software engineer recently laid off from a FANG adjacent tech company. Today's May 20th, and today is like the official day that I was laid off. So I got my notice, I don't know, 6, 7, 8 business days ago, but it is effective today. So happy anniversary. We're doing Leetcode to prepare for the job search. In front of us is latterly.io, which is an open source website with all kinds of tips to help you learn to code and land your first or next programming role. The Leetcode kata is a set of practice problems based on Leetcode. In the standard kata, there are 12 problems. In the expanded set, there are 20 problems. And this is an evidence-based, research-based set of problems to help you have high coverage of the types of questions you will be asked in a whiteboard or coding round interview. And so I think specifically the standard kata gets you like 67% coverage, and the data's in the article. Okay, so for the past few rounds, we've been working up from 1 to 6. So number 1 is 2-sum, and we'll go through 2-sum, 3-sum, and so on. And 5 has been a stickler. But I want to get, so because 5 has been a stickler, we haven't made it to 6 yet. So I want to try to get to 6. This is going to be a 1-hour time box of a stream. And so the way that I'm going to try and improve our ability to get to 6, even if we don't solve it, at least try it, is that we're going to jump past 1 and we're going to go straight to number 4. So 4 will be a warm up, and then 5 will, if I remember, also be easy, but we'll see. I've been having trouble with recall on that. And then 6 will be new. So I'd like to get to a new one today. With that, let's dive in. We'll dive into number 4, linked list cycle. Thanks for being here, TikTok. Feel free to tap the screen a few times and give it a few likes. If you are on another platform, it only lets you like it once, but thanks for doing that as well. And feel free to drop a comment if you have any questions. Also, if you're on TikTok, you can go to YouTube or Twitch. The link is in my bio and see the full screen. So here's number 141, linked list cycle. It says, given head, the head of a linked list, and we can see from the comment on the right that this is a singly linked list. It only has a next value. There's no backwards or previous pointer. Given the head of this list, we want to determine if the list as a whole has a cycle. And here we get a definition of a cycle. A cycle is if there is some node in the list that can be reached again by continuously following next. So we might call this like an infinite loop. So you never actually, if you're forward progressing through the list, you actually never get out of the list. You just kind of keep going in a cycle. Internally, POS is used to denote the index of a node. That is the tail's next pointer. Note that POS is not passed as a parameter. Let's return true if there is a cycle. Otherwise, return false. We have example 1 where there's a demonstrated cycle, 2, 0, -4, 2, 0, -4. You'll keep looping there. And then in the case where there's a single node, there is not a cycle. Okay, so it seems that even in the best case, I must explore all nodes. So best case complexity seems like O of n. So that's best case, but we want to try to get our worst case time complexity. Is worst case the same or worse? And the answer is that I should be able to tell in 1 pass plus 1 more move. Which is asymptotically equivalent to O of n. Because I should know if I hit a node I already saw. Initial space complexity is O of n for a cache of seen nodes. But on second thought, we don't need that. We can use fast and slow pointers to detect a cycle by collision without a cache nor time complexity reduction. So we use fast and slow pointers. We'll initialize them to the leftmost node. That's going to be head. It's not going to be 0. We'll just say while fast.next and fast.next.next. We call it fast because it's going to make 2 steps per iteration. I also need to check that fast itself is available. So this is like basically like while the fast pointer is allowed to increment. If it's not allowed to increment, we're just going to exit. And by the way, if it's not allowed to increment because we ran into a none value or a null value in other languages, that means there is not a cycle if we ever run into that, right? Because there will always be a next one as long as you do have a cycle. So here I'll say while to do, and then down here I get to return false, because if you ever exit that loop, you don't have a linked list. Does that make sense? Okay. So while you have all these things, if to do, so we'll make some check, that will be the return true case, like there was a collision. If has collision, return true. And then otherwise, we will move the pointers. So fast is going to equal fast.next.next, and slow is going to equal slow.next. We don't need to do any sort of null checking for slow because fast is always out in front. So as long as fast is safe, then slow is definitely safe. Safe meaning that it has a next pointer. So how do we know if it has a collision? Well, it has a collision if fast is equal to slow. So if you're familiar with track and field, the idea here is that you're getting lapped. So if slow is so slow that fast points to the same node, that's like a collision. That means there is a cycle. Do you see why that demonstrates that there is a cycle? Taran says, I just completed the 150 list. Congrats. I'm also on Leetcode grind. Congrats, congrats. Hey, by the time you get to 150, I think you're actually over prepared. Are you interviewing right now? Or maybe you already have a job and you're just doing it because you got the itch. I got laid off. I feel that. I feel that. Hey, join the Discord, latterly.io. If there's anything I can do to help. There's going to be job search tips in the checklist itself, but then also you can join the Discord over there. And there could be even additional tips. But basically, if you are crushing 150, then like you should be good to go on the coding round. And you should be looking at like sysdesign and behavioral at this point, or you should just start applying now. Congrats, that's great work. Okay. So what's going on with this? Is this good to go? Yeah. Wrong answer. What case did I miss? It's the first case. They always start out pointing to the same one. Yeah, it's good. I got practice with BFS, DFS, Canes, Topo, Union Find, etc. for graphs. BFS and DFS, got to get them. We love it. Topological sort is one that I have often missed on, actually. So what we want to do here is make sure that we're skipping the case where they're both pointing at head on that first iteration. Just get it in the wrong order. Yeah, that was it. Just got it in the wrong order. You should try cheapest flights. It's a great question. If you look at the laterally kata, there is a systematic search for the questions that we pick. I'm really not into this whole like, hey, just do questions because they're great questions. Like, what is it? What do you mean great question? I think you're not going by frequency, because cheapest flights is like not one of the most frequent questions, right? Let's look at the list. Even when you say like most frequent questions, then it's like, well, what's your like frequency cutoff? Because like it might be asked like 50% of the time. So you see how these are like 199. These are like super frequent questions. So even to be on this first page of 50, you got to break 85, it looks like. So let's go cheapest flights. Cheapest flights with K-stops, are you talking about? Which cheapest flights? So this is like, yeah, this is like 63% of the time. So it's way down the frequency list, right? I mean, we could do that question some other time if y'all want to like pull up to the Discord or something and make a list of questions that you just want to see for entertainment purposes. But as a matter of preparing systematically for the interview, I would not pick this. Like I just wouldn't pick it. Do you see why? There's more frequently asked questions. I'm using Leetcode. Yeah, so the laterally Leetcode kata builds on Leetcode. So Leetcode is 150. The Leetcode kata is only 12. Just give it a read, y'all. Just give it a read. Okay. I think I've done so many that the only ones left are not that frequent. Yes, and that's actually something to be mindful of, Taran. That's why the kata is a repetition-based approach, where you do the frequent ones over and over and over. Because I have met people who have done like 400 problems and they still bomb. And it's like, why? You've done 400 problems, but you've pretty much like only done them once each. And for some people, there's like this fear of doing the same problem over and over because it's like too easy or cheating or something. It's not. It's preparing. Like whenever you were learning addition and multiplication, didn't you do the problems over and over? This is how we learn. I need to do sys design practice. Yeah, I'm with you. I'm with you on that. Okay. We did cycle. Let's go over to the palindrome linked list. Oof, this one is my nemesis because this one is tricky in my brain to do. Okay, it's already wiped out. I've done so many problems over and over, it's actually crazy. Okay, cool. So then if you get a problem like that, you're going to knock it out, right? That's a green flag. Great job. Given the head of a singly linked list, return true if it is a palindrome or false otherwise. By palindrome, we mean words like mom, dad, race car. They're the same forwards and backwards. And here in example 1 is a numerical representation of a palindrome, 1, 2, 2, 1. Also, lone digits, 1, 2, 3. Lone digits will always be palindromic. Same forward as backwards. And in the case where it is a palindrome, we return true. In the case where it's not, we return false. We must explore every node to determine return value. So time complexity is O of n. This is a trivial problem if we use an array copy or string or similar. That takes O of n memory. A more efficient but more complicated thing to do is to reverse the second half of the list, then compare halves for checking without a cache. That has space complexity of 1. So we're going to try and do that more complicated thing. And so basically we want to find midpoint. We want to flip list from midpoint to end. And then we want to traverse from midpoint to end concurrent with start to midpoint to check for palindromicity. Don't you feel cool when you say like big words? Palindromicity. If I can spell and pronounce palindromicity, I get a Google job, right? That's the bar. That's the bar for a Google job. Say palindromicity 3 times fast. Thanks for the follow. Quick reminder, if you're on TikTok, first of all, I'd appreciate some likes on the video. That helps the algorithm send it around. We can educate more people. More than that, you can go to my bio and see the links to YouTube or Twitch, and you'll be able to view the full screen if you're having trouble seeing the screen. Thanks so much for the likes. Ahmad says, what question is this? We are on number 234, palindrome linked list, Ahmad. Okay, so here is the high-level approach pseudocode. We need to define reverse linked list. Don't you love the reverse linked list problems? Thank you. Let me go try and solve it and come back. All right, bet. So to find the midpoint, we can do like we can pass through it once and then calculate the length with a integer outside that we're just incrementing, and then divide that by 2, use the floor math, and we have a midpoint integer. And then we can step through a second time and then sort of like freeze a pointer at that integer. So we can do that. That is not necessary. There's another way to do this. We're going to need a fast and slow pointer anyway. The reason we need a fast and slow pointer is we don't actually. The way I just described, both of them would be perfectly adequate. Why do I want a fast and slow pointer? I think it takes it from like a 2 pass to a 1 pass to locate my pointer at the midpoint. I don't think that's a big deal, but I'm going to do that. Now, how do I reverse that thing? So let's say I got my pointer to the midpoint, and I want to reverse just this piece. I can just pass that node in there. So here, this will be head. Right. Okay. So as far as this method is concerned, I'm getting the head of a contiguous list. Could we not use a stack? Yeah, you can use a stack. I already talked about that. This is a trivial problem if we use an array copy or a string or similar. So a stack would be similar. Yeah, no, you can do that. It's just way too, it's not the most efficient thing. So that's going to take O of 1 memory instead of, that's going to take O of n memory instead of O of 1 memory. You see what I'm saying? So like you're giving the easy mode solution. This thing is labeled easy, right? So you're correct in giving the easy mode solution, but what I'm trying to do is the hard mode solution. Okay. I think we have a plan here. I think we have a pretty good plan here. So let's start coding. Fast is head. Slow is head. And so how do I increment my fast and slow? We can use the same pattern as I did before. While fast and fast.next and fast.next.next. Then fast equals fast.next.next. And slow equals slow.next. Okay. This will continue until fast falls off. In this case, we're guaranteed no cycles. Do you need fast.next.next? Yeah, you do. No, I don't think you do, because if I set it, then you'll come back around the next. It'll just add one iteration. Let's try that. I think you're right. I think it just saves us one iteration, which is like not a big deal, right? How do you suggest learning any programming language? Check out latterly.io. I have a detailed checklist for this. There's the standard checklist, which teaches you how to program, basically, and you can sign up for free. So I won't get into that here. Okay. So now slow. Now I want to reverse after slow. So second half reversed equals reverse linked list of slow. And now I'll do like new head. I don't know. What do we call this thing? I'll call this comparator. Second half reversed head. So while we have those things, if it's going to be .val or .value on the node, it's .val. So if they're different, it's not a palindrome. And if you make it past that gate, then you are a palindrome. If you get here, it's palindromic. Look, I've said palindrome, I've said palindromicity, I've said palindromic. Where's my Google job? Hook it up. Chat, if you work at Google, refer me. Maybe the real test is you have to say palindromic forwards and backwards. I haven't gotten that far yet. I'm just a senior. I'm not a staff until I can say palindromic backwards. Okay. And we also need to step forward. Comparator is comparator.next. So this is not fast and slow at this point. We're just we're like node by node, iterating and comparing. For senior, is it most sys design? That's all like subjective. So when seniors tell you that most of the senior interview is system design, the way I interpret that is they are saying for them, they had to spend more hours preparing for system design. And that's going to vary person by person. Me personally, like, I hate to say this because it sounds like, how do I say this and not sound dumb? In the past, I have spent more hours on coding interview preparation. I think that's fine to say. I don't think I got canceled for that, right? Anna James, thanks for coming in from Twitch. How are you? Yeah, so some people need to spend more time prepping for system design. Some people need to focus more on behavioral. It's kind of like person to person. For me, my problem is memory. I have like a memory problem, basically. It's hard for me to remember things. So I have to drill it over and over and over to remember it. But the behavioral stuff like comes pretty naturally to me. I will say getting to staff level at the behavioral interview is like a whole lot harder. So I hesitate to call any of this stuff easy. Like getting a job at Google is just not easy. But if you're talking about relative easiness, I think I've already disclaimed, I think that varies by person. But now if you're asking about me specifically, for me specifically, at the senior level, I think the coding round is relatively hard compared to the behavioral round at the senior level. But at the staff level, now I think the behavioral interview is relatively hard. Because anyway, maybe I'm just not good at giving my behavioral answers, which could totally be the problem. Once I fix that, maybe I'll say it's easier at that time, but we're not there yet. How are you? I'm doing well. Thanks for asking. Okay, so this looks pretty good, although I need to implement the method here. Reverse linked list. That's going to be a self dot. And we're on the solution class, so I need to give it a self argument. Okay. Same issue here. Pull up to the Discord then. Accountability partners are a power tool. Like I almost want to say a cheat code. If you can get a practice partner, do it. Do it. As a senior, I agree with what you just said. Thanks, Left Beef. Dope name, by the way, Left Beef. Okay, I'm not getting distracted. Great job. Thank you for the participation, chat. I'm going to turn my eyes toward the code for a bit now. So as I review this, we got fast, slow. We're finding the midpoint. Okay, so slow down here. We're going to reverse slow. And what I'm ending up there is basically the last node, but it's going to be pointing reversed. And so now I can say, like in the case of race car, they're both pointing at R. Then they're both going to move to A. That's what I have with this comparator stuff. I think it looks good. I think it looks good. All right, now let me, drum roll, please. Let me now reverse a linked list. So you want to start with none. So while head.next, priv, let's see, priv is going to start out as none. Nope, I totally am blanking on how to do this. So I have where I'm going, and I want to flip that. So head is going to next, and then next is going to next.next. Old next is head.next. Old grandchild is head.next.next. Okay. So you were going to go over there, and now I want to reverse it. So I want there to go to you. So I want old next dot next to equal head. Oh, let's see. I shouldn't call it head, should I? Let's say cur. Cur is head. So I'll say while cur dot next. Why is head white? I guess that's fine. Okay. So you were going over there, but now there is coming to here. Old.next is equal to cur. This looks good, but how am I connecting my priv? Cur.next is priv. Did I take care of it? So I reverse the next node destination. Yeah, I guess I don't need this thing. So I reverse my next node destination. That's what I did. And now I'm also reversing my current node next destination. Good. The problem is I have not incorporated priv properly. Okay. Priv is old next. By golly, he might have done it. By gosh darn, he might have done it. I don't know. Let's see. Is this error? Cool. Got it half right. What IDE is this? This is Leetcode.com. Leetcode.com has its own built-in IDE. What problem are you working on? 234 palindrome linked list. Thanks for being here. Wouldn't the best solution to be to get the mid of the linked list using fast and slow and start comparing the end and beginning like a two solution pointer on our right? This is exactly what I'm doing, right? So here's fast and slow. Then I reverse the second half. Isn't that exactly what I'm doing? Okay, so Anna James says, are you a programmer as well? Yes, indeed. Yes, indeed. Didn't see the top. Nice. Okay. Okay, so I need to print some stuff because it went wrong at some point. So 1221 is true, but it's like this portion got skipped. So this one, which should be false, is returning true. Why? So let me print these. I'll just print a delimiter so we can keep our logs kind of separated. And then I'll print this and this. Okay. So here, none. What is none? Second half reversed head is none. Oh, I didn't return out of here. Golly. What kind of diddly? Am I going to get canceled for saying diddly? I don't actually know what that means. I think it's a fake word. So what am I returning here? Am I going to return cur? I don't know. I guess I'm going to return cur. List node has no attribute value. Doesn't it? Oh, it's val. Okay, sorry. That's kind of a green flag though, because it means we're getting into the loop. Cool, so now we got the false right and we got the true wrong. Once you do so many, it seems easy though, it's worth it. Yeah, I agree with that. Repetition is key. So here, the second half reversed head is 2. Why would that be the case? I think I'm flipping the associative directions, but then I need to actually do the traversal. So that's one thing that could be going on. So cur is head, and I never actually traverse. Yeah, let's do that. While cur.next. Oh, I do traverse here. Cur.next is priv. Priv is old.next. How about cur is cur.next? I don't know that helps. None type has no attribute next, while cur and cur.next. Oh. Did that work? Nah, come on. That can't work. Repetition is the mother of skill. There you go. Is that a saying? It sounds like it should be a saying. What is this? I'm bachelor software engineer and still fresh about code. Well, this is code. This is Leetcode. Okay, so what happened here? None. Right. Okay, so I don't want to return none here. While cur and cur.next. While cur and cur.next. Oh, am I doing some sort of falsy truthy check on the value? And because it's 0, got me into an edge case. Your while loop should have 4 lines. Whoa, 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 whoa. Whoa, 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 whoa. You might be right, but like, let's not give me the answer here. Okay. So just a clue. All right. Okay. Thanks, GG Manny. Appreciate you. Let's see. Run the test case on paper. You'll get what you have wrong. Okay. I guess I'm trying to work through this in my head. Maybe that's not fair to y'all. So yeah, let's write it down. So we go over here. Where do we end up at fast and slow? So here's our test case 1, 0, 0. They're both pointing at head. Fast goes fast and next.next. So fast is pointed here. Slow is pointed here. Then fast terminates. So slow is left at the midpoint on the mid 0 as we expect. So we're looking good at this point. Okay. Then we come down here. Something goes wrong in the reverse linked list, basically. Because here, second half reverse head is printing as none. So it's unexpectedly none. Anna says, I'm from Texas, by the way. What's up, Anna? I'm originally from Austin, but I live around DC these days. I don't want to say it because it'll ruin it for you. Thank you. Yeah, chat, please do not say the answer. Please do not say the answer. But it is a good point that I should walk through this test case, like kind of show you what I'm doing instead of just trying to do it in my head. Which is a good interview tip, by the way, right? Okay, so here, when I pass in slow, so here's slow, what I'm getting is none. And that is where my brain is breaking. So let's go down to the reverse linked list part. Okay, so here we are at mid 0, which is IDX 1. So we're at index 1, and I say, hey, current is head. Okay, cool. And then I see priv is none. This is a technique that I need. I need that priv is none because I'm going to basically flip my linked list, and I want my node that's previous to the first node to be none, because that's equivalent to the end of the list, where in the non-reversed situation, the node after my last node is none. Do you see why I'm doing that technique there? Okay. So maybe I should be attaching it differently, but at some point I need to attach a prior none. Let's see, where do I want it to be? I want it to be the head.next. Head.next should be none. Post reversal, head.next should be none. All right, so far I'm happy with that part. Now let's get in over here. So as long as we have a current node, we need that current node so that we can check next. What about needing a current.next? I think that's not good. I think that's not good. Maybe it should just be while cur. Why is your screen so blurry? It's TikTok. I don't know. Is that better? Maybe I had it at a bad angle or something. Is that a little better? Thanks for letting me know. By the way, you can go to YouTube or Twitch. Link is in my bio and see the full screen. Says, yes, that's better. Okay, cool. Yeah, thanks for letting me know. So there's a problem somewhere in here, but I'm not exactly sure where. So I said maybe this is it, but I'm not for sure. So let's keep going. So in my 3-link model, and this is where like a chart really helps, right? All right, let's do a chart. Because I'm picturing this in my head, but that doesn't help you. So where's the middle of the screen? 1, 2, 3. Okay. So here I have cur. And here I have cur.next. Maybe that's all I need in my little diagram. I'm not sure we need this dude. Bye. And then there can be nuns on either end. So let's do like a little black dot for a nun representation. Spray paint, I don't know. So here's a couple nuns, right? What's easy to read? Red. So at first you're going over there, but now I want you to go the other direction. Blue. So we want to change from red to blue. Want to change from red to blue. Yeah, Leetcode does these diagrams way better, don't they? This is awful. But that's what we're trying to do. So I'm at cur and I'm pointing to my next one. I don't want to point at the next one anymore. I want the next one to point at me. I don't want to point at the next one. I want the next one to point at me. So let's go see if I did that in the code. Okay, so here I am at cur. I don't want to point at the next one. I want the next one to point at me. So here I said cur.next is priv. Maybe I should say cur.next is cur. Yeah, that was a huge mistake. That was a huge mistake. Okay. I don't want to point at the next one. I want the next one to point at me. Cur.next should equal cur. Cur.next should equal cur. So the next one will point at me. I think that's right. So even though this line is right, I'm not sure the whole loop is right. So cur.next. Whoa, what happened here? Okay, so cur.next will point at me. Great. But now cur.next should point at the last one. Okay? So now my blue are in place. Now it's just a matter of who is priv. I think you need a temp variable. I do. Yeah, my temp variable used to be old next. So you can call it whatever you want, but I need some sort of temp variable. Yeah, I need a decoupler. But the purpose of that temporary variable, like what's it for? The purpose is so that I can find the right prev value. That's the purpose. Let's see. Old next still makes sense to me. Old. Maybe just old instead of old next. So old is cur. Sometimes called temp. I think this is going to be my temp value, basically. So old is cur. Let's see. All I need to do now is navigate. Where is cur? So cur is head. Cur.next is priv. Oh, yeah. So the navigation should maybe happen early. Cur equals cur.next. When to do the navigation? This is the tricky part. So when do we do the navigation? I want to navigate before the reversal. No, I want to navigate before and after. I want to do both at the same time. That's why I need this old. So old is cur, and then cur is going to go ahead and navigate. Okay, so we have old, which is like before my navigation happened. And now here, if I do this, won't I create a cycle? If I do this, won't I create a cycle? Yeah, I will. If I set the grandchild, I will create a cycle. I think I'm going to time box this to 5 more minutes and I'll look up the solution if I need to. Oh man. Isn't this embarrassing? I've reversed a linked list like a bunch of times and I'm like, I forgot how to do it. Doesn't that show you how rusty I am? Okay. So in chat, I see some hints coming in the chat. I'm trying not to look at them. So I'll look at it in the next few minutes, but I haven't thrown in the towel just yet. Okay, so I kind of feel like this. Let me not set the grandchild. So let's just say I don't do that. Let's just say I don't set the grandchild. So I store a reference to the old one and then I navigate the new one. Cool. And now I want to reverse in a way that doesn't create a loop. Reverse old to avoid cycle creation on cur. So if we want to reverse old, then old.next is priv. Ooh, this looks kind of good. So old.next is priv. And then priv becomes old. This part I'm not sure about. So the next time, what am I doing with priv? I'm not doing anything with priv. What I want to happen is my cur.next needs to be priv. No, old.next is priv. Yeah, cur.next is priv, like outside of the navigation. So old.next is priv. That works. That works. I don't need to redirect the grandchild. I can just redirect the child only. And when I get to the end of the list, I should be good. So yeah, priv is old. And then the next time around, that's pretty good. Let's see. Okay, I was accepted. How often do you do Leetcode? During my job search, so like these days, it's Monday through Friday, every day. Monday through Friday, every day. Thanks for the follow. Rupak on YouTube, hello, hello. Yeah, so I try to do an hour a day, Monday through Friday. Some days I'll do a little bit more, but that's like kind of what I put in my regular schedule. So what's wrong here? 1, 1, 2, 1. Something's wrong. What do I have printed? Val 1, next is none. So this is the problem. That linking is failing. It should say next is 2. Should say next is 2. Oh, okay, hold on. Down here, Val 1, next. So this is like 1, 1, 2. Do I have an off by 1 issue, basically? I have a SoFi interview coming up. Good luck, good luck. How long did it take you to land your first job? It took me a year to get my first job, but I don't have a CS degree. But it took me a year to get my first full-time programming role. Okay, so something is wrong here. All right, let's look at the solution. We hit a time box. Da 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 da. So previous is none, current is head. I think I got that part. Heck yeah, I got 2 lines. Previous is none, current is head. While current, and I said while current and current.next. Okay, hold on. Is that going to fix everything? No. Okay, good. I'm glad that it didn't, because I would actually be a little bit embarrassed if I didn't try my own to do. So while current, oh, and we end up returning previous. What? That's crazy. No. I hope that doesn't fix it. Yeah, this is Python. Fail, fail, fail. Nice, TLE. Okay. If we're more than 2 lines away from the solution, then I don't feel bad looking at the solution. If we're only 2 lines away, I actually feel bad. So celebrating the TLE for that. Okay. I find Leetcode solutions to be helpful. Yeah, me too. Me too, me too. So while current, the next node is current.next. Okay, so they don't do caching on current to old. It's like a forward-looking cache. So my temp variable, I'm surprised these are not isomorphic actually. So my temp variable is on the old cur. Their temp variable is on the next node. So they do a late navigation. Here I'm doing an eager navigation and they're doing a late navigation. I'm surprised those are not isomorphic actually. It's the next node here is basically to save the next value. It's just a temp. Yeah, I know. And what I'm doing, I have a temp on old. So do you see why I have a eager navigation with an old temp and they have a lazy navigation with an eager temp? Do you see how the pattern is flipped? I'm surprised they're not isomorphic. Like I kind of think they're equivalent. Let me go ahead and ask GBT here. Linked list palindrome algorithm. Here, next node is used as a temporary variable. Consider a similar solution that stores the old value as a temporary variable. Between these two patterns, one can be said to use eager navigation on the current value, while the other uses lazy navigation. Are these patterns equivalent? Why or why not? I think the answer is going to be they're not equivalent, but I need to know the reason why to get it in my head. Taran says, well, I see it as work from the end to the front. Access the last node, reverse the link. It's not resonating, man. I hear the words, but it doesn't compute in my brain. Both patterns achieve the same result. They reverse the pointers of the linked list nodes. The key operations are present in both patterns. Are they equivalent? So GPT-4o thinks they are equivalent. GPT-4o thinks they are equivalent. Let's replace it and see if that fixes my problem. I mean, there's an easy way to test this, right? So let's just copy the eager pattern. So let's see if we get a TLE or not. Yeah, we got a TLE either way. So they're equivalent. So your cache is your cache, and it doesn't matter. It doesn't matter for the purpose of reversing the list. It doesn't matter whether your cache is eager or lazy. It doesn't matter. I think the only impact might be whether you return cur or previous. That's the only impact that I can think of. So the problem is not there. The problem is like, what is the problem? This is going to eventually terminate. So the problem I don't think is here. Is the problem here? Let's see. The problem might not be in this method at all. Okay, cur is getting navigated out. What about if I return head here? No, I don't want to return head here. What do I want to return so that I can get the top? So this is giving me the 2. Yeah, that's right. So I do want to return prev in either case. So whichever temporary variable I use, it doesn't matter. I want to return the node before. Why do I want to return priv? Because intuitively to me, priv.next is pointing at a none. Nope, priv is just pointing at old. Priv is just pointing at old, and old has already been reversed. So when I return priv, I get the last node pointed in the right direction. So that's good. I don't think I have a problem in my linked list reversal logic. I think I have a problem somewhere else. So let's look. Gigi, you can go ahead and give me the answer if you want. It might be fast.next and fast.next.next. What do you mean? Over here? That is a big boy, eh? What's going on over there? And we still got a TLE. So I think it's something over here. Oh, hold on. Let me just get rid of my prints. Are the prints just slowing it down? Oh. It was just the print statement, bro. All right.